Hi guys, welcome to the video today on combining like terms or simplifying variable expressions. So we've looked at how to do this with algebra tiles, meaning we had different kinds of tiles. Sorry, let's get rid of that one. We had different kinds of tiles that meant different things. So if we had a couple green tiles and then we had a couple red tiles, we could kind of combine them, and we talked about the idea of these two being zero pairs and these two kind of canceling out. Okay, now we're going to do that kind of without all those different things to help us out. We're going to do it with just the numbers. Okay, but we're going to always kind of go back and think about what it would be without the tiles. So to simplify variable expressions, things like this: 5x plus 4x minus 7. The process is called combining like terms. Combining like terms, and you'll hear me abbreviate that CLT sometimes. We're going to combine like terms to simplify variable expressions. So there are going to be certain things that we can add together and certain things that we can't add together. There's different rules that we have to follow, just like in math all the time. There's different rules for different things. But this is something that you will see all the time in future math classes. It's a very important skill that we build on. Just like addition and subtraction and multiplication and division, in elementary school, this process of simplifying variable expressions is very important, especially later on in high school. It applies to all different kinds of math. Okay, so what we have in front of us here, the blue things, that blue arrows pointing to the 5x, the 4x, and the negative 7. Those are called terms. T-E-R-M-S, terms. So go ahead and label that, so you have that there, pointing to the three things we have in front of us here. Let me show you what that is. The terms are, if I can get it small enough. There we go. 5x, 4x, and negative 7. Now notice that negative actually goes with it. That's very important. So we have 5x, 4x, and negative 7. Those are the terms. Okay. The red thing, the red arrows here, are pointing to just the 5 and just the 4. Those are called coefficients. C-O-E-F-F-I-C-I-E-N-T. Coefficients. Just the 5, just the 4. Those are our coefficients. So if we look, just the coefficients are right here. The 5 being multiplied by x. We're just going to say the 5 is the coefficient and the positive 4. Okay. 7 is not a coefficient because it doesn't have a variable after it. And the last thing, the black arrow there, is for what's called the constant terms. And if anything is constant, that means it's remaining the same. It's not ever going to change. Since there's no x with it, there's no number we can plug in to kind of change that number. It's always going to be minus 7. So that's why it's a constant term. So that negative 7. All right, so next up we have a couple different examples. We've kind of talked about these things: terms, coefficients, constants. But we want to put a definition to all these things. So terms are the parts of an expression that are added together. And those were the first three things: the 5x, the 4x, and the negative 7. So the terms are the 5x, the 4x, and the negative 7, parts of the expression that are added together. And notice it does say the word added there. We're going to think about this as really plus negative 7. And that's why if we make it a plus, it's really negative 7. So you can see that as two ways. You can either see it as minus 7 or plus negative 7. But either way, our term is negative 7. Coefficients are the numbers that are being multiplied by the variable, like 5 and 4 in this example. 5 is being multiplied by x, and 4 is being multiplied by x. So the coefficients are just 5 and 4. We don't say it with the x, just 5, just 4. The number being multiplied by a variable. And if you need to have more time for some of these, push pause, please. Next thing is constant term. That's anything that does not have a variable. If it doesn't have a variable, there's no way we can plug a number in to make it change. So constant terms are always remaining constant. They're not going to change with different values of the variables because there aren't any variables. Okay, and like terms. This is the big idea, the big important idea. Okay, like terms is definitely what we need to spend a lot of time thinking about. Okay, and if we look back or think back to the example we did with the algebra tiles, these are the like shapes. So, you know, a long rectangle and a long rectangle, or a square and a square. Those are different shapes that are like terms. So the definition of that is two or more terms that have identical variable parts, or just integers, are also like terms. So like 7 and 5, those are like terms, or 3 and 2. Anything without x as well. All right, so that's kind of the big idea, a lot of the vocabulary there that we got to talk about. But let's go back and just kind of look at our big thing one more time to review everything. What we have here, put the spotlight on and we'll kind of look at everything. So terms. Those are the things that are separated by addition and subtraction. So here's a term, 5x. And then we have addition, so this is positive 4x is the next term. And then negative 7, that's our last term. Coefficients are the numbers that are existing or coexisting with the variables. The 5 would be a coefficient. The positive 4 would be a coefficient. And that's it. The 7 would not be a coefficient. Constant terms are the things without variables. And you usually find them at the end of polynomial expressions. So here the constant term would be negative 7. Okay. And one thing I'd like you to add in here that I just thought about while I was talking about it. For coefficients, I usually think of the word coexist. Two things that coexist together are living together, are kind of, you know, existing at the same point in time. So the variable and the number are together. That's how I like to think about it. All right, so this is not in your notes, but just some examples here. We're going to identify all the like terms. So anything that has the same variable parts to it. So don't be tricked up by the numbers right now. Just look at the variable parts. So let's start with x's. Let's put blue ones around those. X is a like term with other things that have x's with it. So if we look here, none of these have x's except for this one. Do you see other things that are like terms with x's? This one works. Okay. But if you notice here, we can't put a like term with the x squared because it has a different exponent. Okay, so only things with x to the first power are like terms. So that one is not a like term. Do you see any other pairs here? We have a's. Okay, and then we also have just the regular numbers. Anything without exponents, those are called constant terms. Those are still like terms. We can add together 16 and negative 2.4. Okay. The rest of these are not like terms. If you notice, the b squared and the b to the first power are not like terms. We can't add those together. This would be 2 big squares, and this would be 3 small rectangles, and those don't add together. Okay. So that's just a little bit of an example there. When we're doing this, when we're identifying these 4 items here, we want to actually write it with addition. So here's our first example. We will take this whole thing and change subtraction to addition. So we're going to keep the 4n. Minus 7 becomes plus negative 7. Minus n becomes plus negative n. And then plus 9. So now it's all addition. We can keep track of all of the terms. So the terms, once again, were everything that's separated by addition. So we have 4n, negative 7, negative n, and 9. And we're just going to make a list out of that. So we have 4n with a comma there, negative 7, negative n, and 9. Those are all of our terms. And now you can kind of ask yourself, well, do we have any like terms? Are there any of these things that we could add together? And sure, there absolutely are. What we're going to add together are the things with identical variable parts. Okay, so the identical variable parts would be the 4n and the negative n. Likewise, we also have like terms with the numbers, negative 7 and 9. So the way I want you to list this out is we're going to do 4n and negative n, semicolon. That's one pair of like terms. The other pair is negative 7 and 9. Those are pairs of like terms. Here the coefficients are the numbers in front of the variables, the things that coexist with the variables. So we can look back up in our lists right here, or we can look in our whole example over here on the left side here. It doesn't matter. But the coefficients come from this 4n here and the negative n. So the coefficient is just 4. And then, like we talked about a couple times before, if we don't have a number in front of a variable, it's actually a 1, in this case negative 1. So the coefficients are 4 and negative 1. And then we have constant terms, things without variables at all, negative 7 and 9. Go ahead and try this one on your own here. List out the terms, like terms, constants, and coefficients. Push pause. Give yourself some time to really make a nice, neat list here. Okay, here's the answer. If you didn't do it yet, push pause, go back, try it on your own. Don't just copy down what I did. But here are the answers. Terms, everything listed with commas there. Notice we also include the negatives when they are negative. Like terms are, in this case, in pairs. They don't always have to be pairs. There could be 3 like terms or more. Coefficients, notice I list the 4 twice because it was with the x and the y. And that's it there. Alright, now here are our steps for simplifying variable expressions. Okay, what we're going to do is distribute if necessary. Use that distributive property. And in this case, on this page here, we don't see anything. This is kind of going down the left side of your page. We don't see anything that is that has parentheses, so we won't have to distribute. And after that, we're going to use shapes to combine like terms. Here's what I mean by shapes. What we're going to do is group together the things that are like terms. Alright, so we have like terms for the x's, and I'm going to put circles around those to say, those are like things. We can add those things together. And then maybe we'll go with a box around the other pairs of like terms here, because we can add together negative 4 and 17. So here's how this works. We need to do 2x plus negative 1x. So we're going to add together these circles first. And you can kind of think about adding those together. I don't like to put the lines there because it gets kind of confusing. I'm just adding the 2 red things together right now, the 2 circles, 2x and negative 1x. So off to the side, I'm thinking, what's 2 minus 1, or even 2 plus negative 1? And that answer is 1x. This is kind of my thought process over here. And now we have negative 4 plus 17. And you're doing that off to the side too. You can use your calculator for that. Negative 4 plus 17 is positive 13. That is our answer. Here we had 2 shapes that we used, circles and squares. Notice that we had a final answer that had 2 terms in it. In our final answer, we had 2 terms, the x and the 13. Go ahead and try the next 2 on your own using shapes. Alright, here are my shapes. I'll put the shapes for both of these. They give you another second to check your work. We have b terms that we can add together. Maybe we'll put a box around those. Notice I'm including the sign in front of all the terms. So those are the same. And then maybe I'll go to a triangle around these 2 here. Next thing, we have x terms. And these 2 examples are actually together there. 3x and 4x. Oh, and then maybe we'll do a circle around the positive 4 and the positive 2. Those are my like terms. So push pause again, double check final answer here. Okay, off to the side, what we were doing is adding the blue terms together, the 17, negative 3, and positive 6. So we're really just doing 17 minus 3 plus 6. When you do all that on your calculator there or in your head, you get 20b. When you do negative 18 plus 2, remember integer rules, we actually get negative 16. So there's your final answer, 20b minus 16. And last one, 3x and 4x is 7x, 4 and 2 is 6. Final answer there. Now this is where it gets a little more complicated. Here we have to distribute first, and then use shapes to combine like terms. So these are actually some difficult examples here, but I think we can do it. What we need to do is actually distribute -8 through here. So what we're going to do is bring down our 3k, and we're going to do -8 times k. Let me clean up the arrows here one more time for you. We'll do that kind of once at a time there. Alright, so bring down the 3k, distribute -8, and then once again in a different color, I'll do -8 times 2. Alright, when we combine this, we get 3k minus 8k, and then -8 times 2 is -16, or plus -16 there. Once we've distributed, now we're going to move on to combining our like terms. So here we have a 3k and a -8k. In your head, think, what's 3k plus -8k? Or what's 3 minus 8? And that answer is -5. So there is our final answer there. Okay. Next one. We need to distribute. Now we need to distribute, in this case, the -2 through. So we're going to bring down our 4a. -2 times 4a is, I'll go ahead and write it out like this, -2 times 4a. And then we got to distribute the -2 to the -3. Okay. A couple ways you can do this, but I'm thinking of a negative times a negative is a positive, and 2 times 3 is 6. So here what we get is 4a minus 8a plus 6. When we combine this and simplify it all together, using our shapes, we have shapes around the a terms. 4 minus 8 is -4. And then we have 6 at the end there. There's our final answer. We can't add those together because a and 6 are not like terms. And our last one here, we're going to distribute the y. We have 3 times y plus 2 times y minus 18y plus 40. See if you can figure out what we would combine here. We have shapes around the y terms. Those are all the same. And then the 40 doesn't get another shape with it. It's all by itself. There's no like term with that. So 3 plus 2 minus 18. 3 plus 2 is 5. 5 minus 18 is -13. So there's our final answer there. And that's it. Thanks for watching, guys. This is kind of a more complicated lesson. We will spend a little bit of time on it. So if you're a little confused at things, that's okay, especially on this page. But let me know what questions we have coming into class tomorrow. Have a good night, guys.